Dr. D. Sangeeta is currently a senior lecturer at the Department of Chemistry, Anna University, Chennai. She has completed her PhD in the field of polymer chemistry from the University of Madras in the year 2000 and has teaching and research experience of more than 10 years. Her research interests are in the following fields: fuel cells for clean energy, functional membranes for desalination, and polymers for biomedical applications. She has published more than 20 research articles in national and international journals and has more than 40 research articles in national and international proceedings. Presently, she is guiding 6 research scholars for their doctoral degree.
Welcome to the UGC lecture series on the topic of solar energy today. Today, part 1 of solar energy we are going to see. As an introduction about solar energy, we all know that energy is the most demanding and required uh, product which we require for various activities of our daily life. So, there are basically renewable and non-renewable energy sources. Right now, we are making use of many varieties of conventional energy sources which are available in the Earth's crust, which are going to be depleted very soon from the Earth because we are vanishing them for all our utilities in a very great way. But the environmentalists, scientists, and researchers are looking forward to a renewable source of energy where there is no loss or there is no depletion of the energy content that is available is happening. Hence, people are attracted towards all kinds of renewable sources. For example, solar energy is the most wanted or most important type of energy that is available naturally for us, and people are looking forward how to maximum utilize and harness energy from such kinds of renewable energy sources. Under this list of renewable sources, we have solar, we have tidal energy, we have wave energy, we have hydroelectric energy, and various forms of energies that are available abundantly in our earth. So, one among these types of renewable sources is the solar energy. Today, let us begin with the part 1 of solar energy. And this energy is supposed to be the ultimate renewable resource of energy that we are looking forward. It is basically or primarily the energy which is coming from the primary source of energy, which is nothing but our sun, solar energy. So, the energy can be grouped into two forms. One, you call them as renewable sources of energy, the other one you call it as non-renewable energy sources. When we talk about the renewable sources of energy, you have biomass energy, you have solar energy, hydroelectricity or water energy, that is the energy stored in the water. You have wind energy, you have geothermal energy, wave energy, tidal energy, and so on. All these energy forms are abundantly and easily available for us. The only point is, how do we convert these abundantly available renewable forms of energies into our useful forms of energy, especially the electricity? That is the challenge behind converting this renewable forms of energy for our useful requirements. The other category of the energy sources is the non-renewable systems. Under the non-renewable systems, you have the oils, refineries, your crude oil which is coming from the refinery, natural gas, you have coal, lignite, nuclear energies. All these are also coming from the earth, but they have a limited value for them. That is, they have an end for their sources. Once they are going to be depleted or used for our various requirements, there is going to be an end for all these kinds of energies that are available in our earth's crust. So they are termed as non-renewable energy resources. Now let us focus upon the renewable energy resource which is coming from the solar or solar energy. What is solar energy basically? Solar energy is the most readily and easily available form of energy, source of energy. It is the most important non-conventional source of energy because of the following reasons. Number one, it is basically non-polluting. When compared with the conventional energy sources, solar energy is non-polluting. By the way, what we mean is they don't produce any harmful effects or they don't produce any unwanted, undesirable toxic materials or pollutants which may be dumped into our environment. So it is basically non-polluting in nature when compared to the conventional forms of energies. Secondly, the solar energy is inexhaustible. There is no end for them. We keep getting the solar energy from the sun. It is inexhaustible and sustainable. It's there for a long time, sustainable, unlike the conventional energies that are derived from the fossil fuels available in the earth. Thirdly, the solar energy is also freely available. It is abundantly available and does not belong to anybody particularly. So nobody can claim that this energy is my property or whatever it is. It is freely available everywhere to all of us. Only point is, how do we make use of this energy which is abundantly and freely available to everyone? How do we convert them into the various forms which we require for our applications? Fourthly, it also reduces, this is very important, the greenhouse effect. Due to the greenhouse effect, we have various problems including global warming and so on. So this particular conversion of solar energy to our useful energy is not going to produce any greenhouse gases which are not desirable for our activities. Based on these points, the solar energy is supposed to be the most important and interesting source of renewable energy for our various energy requirements in our regular life. Let us move on to the origin of solar energy, where this solar energy is coming from. What is the origin of solar energy? The solar energy basically originates from the sun. It is originated with the thermonuclear fusion reactions that are going to occur, that are occurring every day in the sun. Basically, the thermonuclear reactions can be classified into fusion and fission. Fission is breaking down of a bigger or a larger nuclei into smaller ones. Fusion is combining together smaller nuclei into bigger one. In solar, in sun, the hydrogen atoms are combining or fusioning to form a bigger molecule or a bigger atom, namely the helium. So whenever the fission or fusion reactions are going to take place, which are going to be the nuclear reactions, thermonuclear reactions, there is a large amount of, abundant amount of energy that is produced during the process, during the fission as well as fusion. So as far as the fusion reaction that is taking place in the sun's atmosphere, there is a large amount of energy that is being produced. So that is what is the source or origin of the solar energy in the sun. It basically represents the entire electromagnetic radiations. So all the radiations which are going to be formed when such fusion reactions are going to take place, they can be grouped down into various regions, and the whole spectrum, you call it as electromagnetic radiation or electromagnetic spectrum. So the entire electromagnetic radiation, which is represented by the visible light region, infrared region, ultraviolet region, X-rays, radio waves, cosmic waves, and so on. So every region is termed differently depending on the difference in the wavelength of the radiation. For example, this particular picture explains the energy with respect to the different wavelength of the radiations. So here if we see, these are all the radiations of short wavelength or short wave radiations, you call them, which have a smaller wavelength value, and when you proceed in this direction, you can see there is an increase in the wavelength. So from the shorter wavelength radiation to the longer wavelength radiation we are moving. Every place is split into different regions. Initially this particular region you call it as X-rays, then the slightly higher wavelength you call it as UV radiations, ultraviolet radiations. Then we move on to the very important region called the visible region. This is the region where we can see the different colors which is visible for our eyes. So about 43% of the entire wavelength region radiation which is being produced in the sun belongs to visible region. That is, the 43% is coming over here. And once again, if you are going to travel through this direction with the increase in the wavelength, let me say here it is 700 nanometer. Between 400 nanometer and 700 nanometer wavelength is the visible region, which is about 43% of the radiation which is coming from the solar or the sun. Then we try to proceed in this direction. It becomes infrared radiation, slightly higher wavelength, and microwaves, radio waves, and so on. So with the increase in the wavelength value, there is a decrease in the energy value. That is, there is a decrease in the frequency of the wavelength, which is going to appear in a short length, and there is a decrease in the energy value. Hence, we can say with a decrease in the wavelength value, there is an increase in the energy. Therefore, we can say X-rays, they have got the very high energy and very high frequency. When you move on in this direction, the wavelength increases while the energy and the frequency decreases for the different wavelength radiations which belong to the different wavelength values. So, the entire electromagnetic radiation is available in the solar radiation, but the maximum amount of radiation, they belong to the 43% of visible light radiation which is coming from the sun. So this is the basic origin of the solar energy from the sun. Now let us move on to the advantages of making use of this solar energy when compared to any other conventional forms of energy. All chemicals and radioactive polluting byproducts of the thermonuclear reactions, they remain behind on the sun itself, while only the pure radiant energy is reaching the earth. So this is the most interesting part of this thermonuclear reactions. The thermonuclear reactions which is happening in the sun is very far away from us, and the whole of the reaction is taking place there. And at the site of the reactions in the sun's atmosphere, those polluting byproducts, chemical byproducts, radioactive materials, all these polluting materials stay behind in the sun itself, and only the pure form or the good energy which is not polluting us, which is not creating any problem for us, alone is going to be radiated to our Earth's atmosphere. Of course, UV radiation is a little bit harmful, but we will talk about UV radiation later. So, only the pure radiant energy reaches the Earth without harming us in a very bad manner. Another advantage is that energy reaching the Earth is incredible. They don't have a value, they are invaluable. By one calculation, 30 days of sunshine, if it is going to happen, 30 days of sunshine striking the Earth have the energy equivalent to the total of all the planet's fossil fuels, both used and unused. So that is quite amazing. So that much amount of energy can be harnessed, is possible to take away from 30 days of sunshine when it is going to happen on the Earth. So this is what is indicating the huge amount or the large amount of energy that is available in the sun, and that can be utilized for our various activities when it is going to fall on the Earth's crust. Of course, any system, any energy methods will have its own limitations or drawbacks also. Having looked into the advantages of solar energy, we should also look into the disadvantages or the limitations of using this solar energy for our requirements. Number one is sun does not shine consistently. There is no uniformity, there is no consistency. It may shine or it may not shine. Also, it may have a concentrated or a diffused source, or you may have a very focusing form of energy. So it is not uniform always at all the places. The sunshine cannot be consistently taken. And secondly, solar energy is a diffuse source. So the source of energy that is falling on our earth is in the diffused form. So it should be made into a more focused and a concentrated form of energy, and then it can be utilized for our requirements. To harness such a diffused source of solar energy, we must concentrate the energy into an amount and form that we can use easily, such as the heat or in the form of electrical energy or electricity. Addressed by these particular utility is addressed by approaching the problem through three important stages. One is collection, secondly conversion, and thirdly storage. Collection refers to how do we collect this diffused source of energy very efficiently and effectively. And secondly, how do we convert this collected form of solar energy into various other useful forms, especially it could be converted into heat energy or electrical energy. And thirdly, how do we store them? This is another very important point, because the sunshine is never there always, and whenever it is going to be there, we have to collect it, convert it into some form which can be stored. And how do we effectively store the energy, in what form they can be stored, so that you can utilize that stored energy for your various purposes whenever you require it. Having seen the origination, where the solar energy is coming from and how do we get that energy, and having seen the advantages and limitations of harnessing this particular solar energy, now we will move on to how much amount of energy is available, solar energy is available, and how do we harness them. So how much solar energy is available? The sun radiates energy continuously, consistently and continuously. It is generating energy at the source place. The sun's energy is due to the energy that is released from the thermonuclear reactions, which involves the fusion of hydrogen atoms into helium. This is what is your fusion reaction, which is responsible for such a large amount of energy that is being produced in the solar. The harmful radiations and the cosmic radiations are being filtered off by the Earth's atmospheric gases without making them to reach the Earth. Around 92% of the radiation that is reaching the Earth, they lie in the wavelength range of 315 to 1400 nanometer wavelength region. So out of this, 92% of the region, 92% of the radiation, they belong to this particular region. The visible light which falls in the wavelength range of 400 to 700, more accurately 380 to 760 nanometers, they account for about 43 to 47 percentage of the total radiation that falls on the Earth. Now, let us have a small description about how much amount of energy is originated from the solar and how they reach the Earth, in what manners they are reaching or getting absorbed or transmitted to us. So if we look into this particular picture, 100% of the energy is taken or coming from the sun. Around 24% is being transmitted directly to the Earth's surface. Only 25% of this 100% energy falls in the Earth directly, transmitted through the atmosphere, and 17% are transmitted through the atmosphere. 25% falls directly, transmitted is 17%, and some amount is being absorbed in the atmosphere itself because of the presence of various gases, dust, smoke and cloud and various other materials and components available in the atmosphere. They also absorb this radiation energy, and some amount of the energy, around 25%, is being scattered back into the outer space from the atmosphere. So out of 100%, 25% directly reaches the Earth, 17% is transmitted through the atmosphere, and 25% is scattered by the atmosphere back into the outer space. Whereas what happens to the absorbed amount? Out of this absorbed amount that is getting absorbed in the atmosphere, 9% goes away through the atmosphere, 10% falls directly, 6% is also being transmitted through the atmosphere, and 9% is taken away or scattered away from the atmosphere. So ultimately we can see about 24, 17 and 10, around 43% of the total 100% of the energy falls effectively into the Earth's atmosphere. The surface receives about 47% of this total solar energy that is reaching the Earth. Only this amount of energy is usable. The rest of the energy is not available for us for our utility. Now let us move on to the use of solar energy. Photosynthesis uses only about less than 1% of the solar energy that is reaching the earth. Out of this 47% of the energy, only 1% of the energy is being utilized for the functioning of photosynthesis process by all plants and trees. The leaves take part in this. If it is possible to harness a part of the total energy that falls on the surface of the earth, it would provide definitely a sustainable energy for all the needs and requirements of the human society. So the rest of the energy which is not being utilized by the photosynthesis is again so much and abundantly available that can be sustainably used for our various activities. Such an energy will not only be sustainable basically, but also will be of low environmental impact, as there will be no direct emission of the greenhouse gases or any other pollutants. So it is not only sustainable, but it is also environmentally friendly because it does not produce any greenhouse gases and it does not produce any other polluting materials which is contaminating our environment. Now, the importance or the significance of the solar energy. Solar energy was in use traditionally for a long time since our prehistoric times. In the most primitive manner, they were being utilized. Only few research and developmental activities were carried out in very few countries till the year 1970. Most of the work in order to exploit the solar energy most efficiently remained mainly academic till 1970. We were not realizing its importance practically, but it was there only in the books. As an academic value, it had been taught, or we did not give much interest for the application or the real practical uses of the solar energy till the year 1970. But what happened beyond 1970? After 1970, due to the rise in the oil prices, the effort to exploit the solar energy drastically, tremendously increased and become the mission mode approach. It not only increased drastically, but it became the mission mode approach for all our energy requirements. India, our country, is one of the few countries with long days and plenty of sunshine. So we are very fortunate to have long days of sunshine and plenty of sunshine falling in our country. Especially places like Thar Desert region in India is a zone having abundant solar energy availability, which is suitable for solar energy for a number of applications. India basically receives solar energy which is equivalent to over 5,000 trillion kilowatt hour per year. 5,000 trillion kilowatt hour per year, which is far more than the total energy consumption of our country. So this amount of energy which is being received only through solar form is far more than the total amount of energy that is being consumed by all of us in our country. Solar energy can effectively be used to meet our growing requirements of electricity. Efforts are also being taken efficiently to use the solar energy. Basically, number one, to reduce our dependence on the non-renewable sources of energies, which we are basically depending on right now. And secondly, to make our environment eco-friendly and clean also. So these are the two primary points which paves the way for utilizing the solar energy for our various requirements. Of course, solar energy has become commercialized in our country and various other countries also, but the fullest way of commercialization, fullest utilization of the solar energy should be given more importance, more effective importance, and then they should be practically made into 100% commercialization happening in our future. Now, let us move on to the use of solar energy. How do we putting the solar energy to our utility for our use? Production of electricity using the sunlight. In general, there are two methods which are used to directly absorb the solar energy and to convert it into a more useful form of energy. which is nothing but our electricity, in a cost effective manner. The two methods are thermal conversion and photoconversion. Thermal conversion basically uses a solar trough or a solar collector, you call it as. Photoconversion, otherwise called as quantum conversion, uses the very basic requirement of this is your photovoltaic cell. So thermal conversion is a direct conversion of the solar energy into our useful forms through the solar troughs or collectors, whereas the photoconversion, otherwise called as quantum conversion, uses a photovoltaic cell. So here comes the R&D or the developmental activities that is going on in the second system. How do we harness the most efficient form of the energy in an efficient converting way? Let us see about the details of thermal conversion and photoconversion in the next parts. Today, as a summary, what we have seen today is about the origin of solar energy. We have talked about the advantages and disadvantages of harnessing solar energy. We have moved on to the importance of solar energy when compared to any other conventional forms of energies, and we discussed about the abundant availability or the amount of solar energy available for our use, and then we moved on to the methods of conversion where thermal conversion and photoconversions are the important ones. We will talk about the details of this in the next part. Here are few questions for you. What are renewable and non-renewable energy sources? Why solar energy is considered very important? What are the methods of conversion of solar energy? Thank you.